Hi, this is Math 118, Section 5.7, Factoring Special Products. In this section, there's two types of special products. There's one for squares, and there's one for cubes. You're either going to see the sum or the difference. X squared plus y squared is called the sum of two squares. That cannot be factored. So you would say not factorable or prime polynomial or cannot factor. If they're both cubes and it's a sum, we can factor that one. For x squared minus y squared, that's called the difference of two squares, and that can be factored into x plus y and x minus y. And for cubes, you can factor the difference of two cubes. So you're either going to see the sum of two squares, the sum of two cubes, or the difference of two squares, the difference of two cubes. For the cubes, it's basically memorize the formula. The way you factor cubes is you draw a short set of parentheses and a long set of parentheses. In the short set of parentheses, you write the cube roots of the cubes. The cube root of x cubed is x, the cube root of y cubed is y. If they're numbers, then you have to write the cube roots of those numbers. In the long set of parentheses, you write the first one squared, you multiply them together and put them in the middle, so these two multiply together and write that in the middle, and then you put y squared on the end. Both problems are set up exactly the same way, x squared, xy in the middle, y squared on the end. The only difference is the signs. So if the original problem was the sum of two cubes, then your answer is going to be plus, minus, plus. And if your original problem is the difference of two cubes, your answer is going to be minus, plus, plus. So let me show you a couple examples in both cases in this section. So for example, let's say you have x squared plus 16. X squared is a squared, 16 is a square. But because it's the sum, you cannot factor that. Another example of squares might be b cubed x squared, messed up on that one. Wrong example. The squares I want to show you actually is the example of a to the fourth minus 81. A to the fourth is a square. It's a squared times a squared. And 81 is a square. It's 9 times 9. And because it's a minus in the middle, which is difference of two squares, this can be factored, and you break them up evenly, a squared, and 9 times 9. And then for difference of two squares, memorized rule is one's a plus and one's a minus. Whenever you're done factoring, when you think you're done factoring, look at your factors again and make sure your factors are factored. That part, that's the sum of two cubes. That one is now done. But this part here, you have it, for this part, you have another difference of two cubes, so you actually have to keep going and factor that into a plus 3 and a minus 3. So the final answer for this problem is a squared plus 9 times a plus 3 times a minus 3. So those are just two examples for squares. Example for cubes is this is the one I want to do. It's b cubed x squared minus 8x squared. Now when you first look at this problem, it's kind of confusing because you have cubes and squares, and so you might not know which is cubes or which is squares. What you have to remember is that with every single factoring problem, no matter what section you are in the book, the first thing you really need to look for is GCF, or greatest common factor. This problem here actually has a greatest common factor. If you look at both terms have an x squared in them. So you need to factor out the x squared first. Don't know why that did that. Sorry. Okay. Get back here. So you factor out the x squared first. You're left with b cubed minus 8. So this is factored, but then you have to look at the remaining factor and ask yourself, is the remaining factor factorable? And the remaining factor is a cube and another cube. That's b cubed, and that's 2 times 2 times 2, or 2 cubed, and it's a minus. So you've got cubes. Use your cube formula that has to be memorized, a short and a long. The cube root of b cubed is b. The cube root of a cubed is 2. Now what goes in the first place is the first one squared. What goes on the end is this last term right here, squared, and 2 times 2 is 4. And then what you put in the middle is you multiply those two together and write that in the middle, so that's where you get your 2b. Memorize the signs. If the original problem is minus, or difference, then the answer is minus, plus, plus. Final answer for this example is x squared times b minus 2 times b squared plus 2b plus 4. So just a couple little examples of squares and cubes.